Hello everyone, welcome to the serial communication series. So the topic for today's discussion is SPI. Let us begin. So let us try to understand what an SPI is. An SPI is basically a synchronous serial communication. What are the characteristics of a synchronous serial communication? It has at least one connection for serial data, a clock connection, and a shared ground. And what are the common types of serial communication? We have the SPI, which is developed by Motorola, and then we have the I2C. These are some of the common types of serial communication. Let us now try to understand what an SPI is. An SPI is primarily used for serial communication between a host processor and a peripheral. It can also connect to processors via the SPI. The SPI works in a master-slave configuration, with the master being the host microcontroller and the slave being the peripheral. Here we have an SPI slave. The master is driving the SPI through the data input, and you have the clock line, and the slave drives the data through the SDO output. Let us now try to understand the protocol in bit more detail. So as I mentioned, for an SPI you at least need one master and one slave, but you can have more than one slave. What is the master control? The master controls the MOSI line. So if you see, the master controls the MOSI line, that is the master out, slave in. There is a shared clock line. So if you see, there is this SEK which is shared between slave 1 and slave 2. And then there is slave select lines. The slave select lines basically tells which slave is the address, or which slave the master is driving the data to. So if the slave select of slave 1 is low, the data gets captured in slave 1. If the slave select 2 is low, the data gets captured in slave 2. This is a simple protocol of an SPI. You have the slave select. When the slave select of a particular slave gets pulled low, that means the slave is selected for reception, and the master starts driving the clock. And when the master starts driving the clock, it also sends the data on the MOSI line, and the data gets sent back on the MISO line for the master. So it's a full duplex communication. So for SPI there are serial clock, chip select, serial data in, and serial data out. There is one and only one master. There can be number of slaves depending on the number of chip select lines on the master. It's a synchronous operation. The data is latched on the rising or falling edge of the clock, and SDI on the rising or falling edge of the clock. This depends on the mode, which we'll come to in more detail in the next slides. The operating range for this is from 1 to 2 megahertz. The master sends out clock and chip selects and activates the slave it wants to communicate with. So there are different ways that a master and slave can be set up for an SPI. So here we see a common setup where we have 3 chip select lines, and you have the clock and the data in. The master determines which chip it is talking to by the chip select lines. For the slaves that are not being talked to, the data output goes to high Z state. Here is a second example. In this example, each slave is cascaded. So the output of one slave is the input of the other. When cascaded, they are treated as one slave connected to the same chip select. So here you have a way of connecting the different masters to the different slaves. If you see, all the chip selects are connected to all the slaves. So when you clock in, the data goes in cascaded from one slave to the other slave. So the data goes in from here, and the slave data comes in to here. So it really depends on how many slaves your data size depends on how many slaves are cascaded. So if you want to send data to all the slaves, you need to clock in for more clock cycles. There are 4 SPI transfer modes. You have mode 0, mode 1, mode 2 and mode 3. It is called the polarity and phase. This determines which edge is the active edge of the clock, or when the data should be sampled by your slave. So when the mode is 0, the CK idle is low and it's a rising edge. So a rising edge is when the data is captured. Similarly for the mode 1, it's the falling edge. And for mode 2, it's the falling edge as well. And mode 3 is the one that is usually used more often, and it's on the rising edge of the clock that the data gets sampled. So in this chapter we saw a brief description of how the SPI operates. In the next chapter we will see in bit more detail on some of the common interview topics that are asked in the interview.